Numbers in the real world are messy. When we make up a story, it's really easy to get a really nice, well-fitting model for two numbers. However, when we go out in the real world and make measurements, it's harder to get a model that fits perfectly. In this section, we're going to start to talk about how we work with messy real-world data. And the first thing we're going to need to do is to be able to visualize potentially messy data. So in this example, the data are not going to be messy, but we're not going to know that until we've drawn the picture. If we have pairs of values, our most basic way of visualizing them is what's called a scatter plot. A scatter plot is a graph on two axes that shows the set of pairs in a relation. So it shows a set of pairs of values that we believe are related somehow. Each pair is represented by a dot on the graph. We're going to make a scatter plot by hand right now. Typically, we will use technology to make scatter plots because, well, take a look at how this is set up. In this example, we're told that the weight of a partially filled fish tank is related to how much water it contains. And we have a table showing us X, the amount of water in gallons, versus Y, the weight of the fish tank. And notice that all of the weight numbers are, well, 8 goes evenly into them. And on our y-axis, our grid lines count by 8s. So these numbers are very, very nice. And they're chosen to be very, very nice so that we can actually draw them by hand. So we have the pair 28, 264. So we find the 28 on the x-axis. On the y-axis, 264 is halfway between 256 and 272. So let's see. Somewhere along here, and then up here. When x is 17, y is 176. So 17 on the x-axis is here. 176 on the y-axis is here. So let's see, somewhere along here. There we go. When x is 23, y is 224. So the 23 on the x-axis is there. 224 on the y-axis is there. So somewhere along here. There we go. When x is 26, y is 248. So there's 26. 248 on the y-axis is here. There we go. Next, when x is 16, y is 168. So we've got 16 on the x-axis, 168 on the y-axis. There we go. When x is 13, y is 144. So there's the 13 on the x-axis, 144 on the y-axis, somewhere along there. There we go. When x is 15, y is 160. So there's the 15 on the x-axis, 160 on the y-axis. There we go. When x is 21, y is 208. So there's 21 on the x-axis, 208 on the y-axis. There we go. When x is 19, y is 19 on the x-axis, 192 on the y-axis. Bam. So that is a scatter plot for this data table. And it's a little bit tedious to draw, and it's kind of messy to eyeball on this really kind of fine grid. But if we draw carefully, we can see a pattern in these dots. And in fact, we see that in this case, these points line up perfectly along a straight line, and so that y is a linear function of x. We know a lot about linear relationships now. Since this is a linear relationship, we can just pick any 2 points and use them to write an equation for this situation. Pick the first 2 points in the table. So x is 28, y is 264, and x is 17, y is 176. Again, since this is a linear relationship, any 2 points we pick are going to give us the same equation. Just to help us keep track, I'm going to put these 2 points into a little table. X is 28, y is 264, x is 17, y is 176. And actually, when I put these into a little table, I want to put the one with the smaller x value first. So 17, 176, and then 28, 264. The change in x here, x increased by 11. The change in y, we can use a calculator for that subtraction. The change in y is 88. So our slope is the change in y over the change in x. My slope is 8. Throwing those into the point slope form, I'm going to choose this point because it has smaller numbers. We'll say y minus 176 equals 8 times x minus 17. We don't have any plus and negative. We'll distribute the 8. Y minus 176 is 8x minus 136. And finally, we'll add 176 to both sides. And we'll get y equals 8x plus 40. So we have the equation y equals 8x plus 40 to describe the linear relationship that we see here. Again, because this relationship is perfectly linear, we can pick any 2 points to work with. So we have just made this scatter plot by hand, observed that all of the points lie along a straight line, and based on that observation, created a linear equation that fits this relationship. We can use technology to do the same thing, and that's our next concept.